Welcome, my name is David Rehagen, and in this video today we're going to go over how MapSuite can generate isolines. So it's a cool piece of technology, and we're going to step through kind of the concepts at first and get you a good understanding of them, and then we're going to dive into the code and show you how it works. Just to note that the Isoline functionality is built into the core level of MapSuite, so you're going to be able to use this across the various platforms. So you're going to be able to use it in WPF, desktop, web, etc. This sample happens to be in the desktop edition, but everything you're going to learn here is going to apply. So I guess to start off, what are isolines, or what they call contour lines? And these are the lines that you see here of varying colors, and they denote general breaks between groups of values. So in this particular sample we have well depths, and the numbers by the points represent the different well depths. And as you can see, the actual number of points we have are kind of scattered, they're not even or regular. But the power of gridding and creating these contour lines is that we can interpolate a lot of this data even though we don't have perfect data, and we can see based on this what we think the rest of the data should be, even though we have imperfect information. So I guess the first thing is that we don't generate isolines directly. There's some different intermediate steps, and I guess the first step to really look at is the data itself. So if we go ahead and zoom out, you'll see that I've only generated isolines for this small section, but that there's a whole bunch of other well data that's associated with this. And you can see here that even this well, even though it's not inside the isoline area that we generated, it has an influence on the isolines. And in our sample, we pull this data from a text file. Take a look here. And these are irrigation wells for Gray County. And you'll see that in this file it's pretty simple. We have some latitude and longitude points, and we have well depths. So this data could really be anything. The important part is that you have some points, in latitude and longitude or whatever projection you need, and then you have some other numerical data, whether it's well depths or density of forest or number of or elevation or what have you. And then the gridding and the contour lines will kind of do the rest. Alright, so we've seen the data, and what happens first is that the first step is to load the data. The next step is that we create a grid. And what you don't see here, and we're actually going to turn it on, is that before the isolines were created, we created this kind of this grid work, and it's an intermediate step. And what you do is that you take a particular extent. In this one we happen to take whatever the current extent was when the application loaded, and then we do what's called gridding, and we do what's called interpolation, and the interpolation is based on a grid. And so we said that for this particular one we wanted 80 rows and 80 columns. Of course, we can change these numbers to get a more dense grid or a sparser grid. And then what we do is that we use what's called interpolation, and we go from cell to cell, and we look at all of these different data points here. And we can set certain criteria to say, well, only look at data points that are within a mile or 10 miles or all kinds of parameters like that. And in this particular case, we use an inverse distance weighted interpolation model, so that as things get further away, the power that they have over the cell drops off, so things that are closer affect it more heavily. And we actually go to each one of these cells and we run this calculation. And then what we've done is we've said that we want 25 different breaks from the highest value to the lowest value, and we've assigned colors to those. So then we go through and normally these would just have numerical values to them, but we've actually colored them here to kind of illustrate what's going on. And once the grid is done, the grid is what feeds in to the Isoline layer. And what the Isoline layer does, we kind of zoom in here, so that one's kind of hard to tell. Let's look at one that's a little more obvious. So you can see here that we have a darker green over here, and then on the other side we have a green that's more heavily mixed with yellow. And what the isoline does is it goes through and it draws a nice smooth contour through those differences. You end up getting something that looks really aesthetically pleasing, and it's not jagged, which is what you would get if you actually did the borders of the cells themselves. Now, another interesting feature of the isoline layers is that we have a lot of these labeled, so you can see that here we have a well depth of 501. We're assuming that it's 498 here, 472, 447, and so on. And if we were to come in here and say, let's say, create 35 levels and generate it, then we have a more granular breakdown. Or we could go the other way, and let's say just maybe 15. And then we'd have fewer. So you kind of have to know your data a little bit and get an idea of where you want the breaks to be. But 25 seems to be a pretty good number generally. Now, if you'll notice in this sample, we actually have two different sections here. And this one is called the grid isoline layer. And so this layer has a prerequisite that it needs a grid. And a grid is actually an open standard. It's actually a file type, and inside the grid are just values for every cell. So you can actually go in here, generate the grid, save the grid as a text file, and then you can reload the grid at a later time. So you could come in here and say the row and column count are 300 or 1,000, and you could generate a really big grid, and then you could load it in at some point in the future. The other system that we have here is a dynamic isoline layer, and in this one we take a little bit different approach. I'll go ahead and click it. When you go to this one, we don't have a display grid because we're generating the grid on the fly. But what we do is we always generate it based on the extent. So as you pan, we're actually generating another grid, and we're generating it in memory. And so in this particular way, if you have a lot of point data, you could literally just pan forever, and you don't have to pre-calculate the grid. So this is really great if what you're using it for is for users just to kind of visualize the data and take a look at it. It's a little bit better if you use the grid isoline layer if you want to do analysis to say, I have a polygon, how much of the polygon is in a particular break and how much of it is in a different area. So this is great for just kind of visualizing it. Because we can keep zooming out, and it's just going to regenerate the grid over and over again in memory. So you know, some other things to take away from this is that if we're doing this in memory, it's a relatively fast operation as long as we keep the row and column count low. Of course, as you increase this, the amount of time goes up. So it's really a difference between visualizing it a lot of times and analysis. But another advantage that the dynamic isoline has is that as you zoom in, since we're regenerating this grid on an 80 by 80, you'll see that the detail and the smoothness of the line keep increasing as we go in, because we're recalculating this and we're getting more and more grid cells which give you a smoother line. So this is the code behind the sample form. Everything is in here. In the form load, we're going to go ahead and set the current extent. We're going to load the well depth data from this comma separated values file, and we're going to cache that up here because there's a couple different buttons that we press that needs that data over and over again. So we're going to go ahead and cache it. The next one is we're going to set up the world map kit, and you might not have seen it, but we had the world map kit as the backdrop, so you can actually see, if you look kind of carefully, there's roads and things behind it. And then what we're going to do is we're going to add another overlay that's going to handle all of this isoline stuff. Now, because in our sample we have this dynamic isoline layer and the grid isoline layer, we're going to be removing different layers every now and then from this overlay. So you'll see some code for that in a little bit. But in effect, what we're doing is that we have three basic layers. We have a grid isoline layer that we're loading right off the bat. We have the grid cell layer, and that allows you to see those actual grid cells, so it helps you kind of visualize what's going on. Of course, in a production application, you might not want to show those actual grid cells. And then we show the actual wells themselves with the well depths. So this first method is static, and it just loads the well depths. It's pretty straightforward. It's just a stream reader, and it reads it into a dictionary of data. The next thing that's pretty important is actually creating the grid file itself. So let's run through this. So the first thing is that we're going to get the current drawing extent, and because that's what we're gridding. Now, of course, in the real world, you could make this grid as big as you could make the extent as big as you want or whatever. We're just doing it for this sample. The next thing is that you're going to need to figure out a cell size for the grid. And so in this particular case, remember, we had some text box that said how many rows and how many columns. So we actually take the current extent and we divide it by those cells and columns to figure out what the cell size is going to be. And we create this grid definition. And the grid definition is a class that you're going to need to actually pass into the generate grid call. And basically it encapsulates the current extent, the extent that you want to generate the grid for, the cell size. This -9999 value is the null data value. So if you have something where you don't want it to generate information for, you put that in. And then here we put the well depth point data. And so this is a dictionary of the point shape and double. So you need to pass in that data. Then we're going to go ahead and create a file stream. And the reason is that when we generate the grid and we call the grid feature source.generate grid, there's two different overloads. One overload takes a file stream so that when this method is done, it will actually have created a grid file for you. But there's another overload. We can just take a look at that. Let's see. So so here's the first overload where it takes a grid definition, an interpolation model, and an output stream. The second one takes a grid definition and interpolation model, but it has a return value, and the return value is basically an array of grid cells that represent what the grid in the file would be like, but just all in memory. And so you would use this if you don't want to actually commit the grid file to disk and you wanted to do everything in memory. You could call this, and the resulting would be this array of grid cells. And then there's other APIs down the line when we actually want to create the isoline that take, instead of a grid file, it can actually take this grid cell array and keep everything in memory. So you're going to pass that in. We kind of glossed over this, or I mentioned it a couple times, but this is really important, and it's an interpolation model. And so in this particular case, we have an inverse distance weighted grid interpolation model. And this is inherited from grid interpolation model, which is an abstract class that allows you to inherit from it and introduce your own interpolation models. The inverse distance weighted interpolation model is a very common one, so that's one that we include in our system by default. And it has a couple parameters here that you can use. Of course, if you create your own, you can have your own parameters. It has a power, which has to do with how quickly it drops off as things get further away. And we also have a search radius. So this one we're using double dot max, so it's as far, every point that you pass in is actually going to be used. But you could do some optimization here, and you could say, only things within 3,000 feet or 200 meters or whatever value. And then that speeds it up because it can just ignore certain data points that are far away. And then last but not least, we have the actual stream that it's going to write it out to. So it's important to note that the generate grid is actually a static method on the grid feature source. And so a lot of times with these things is that the grid feature source itself allows you to load a grid and allows you to see it. but a lot of the methods that allow you to create things are going to be static on it. So the same thing with the Isoline. We're going to see that in the grid Isoline layer there's some really nice static functions that allow you to do things without actually creating the class. So this creates the grid file, and then the next step in the process is we're going to create the grid Isoline layer. And actually the first step of this is to create the grid file. It's just this this method is a little bit out of order. And to create the grid Isoline layer, there's a couple pieces of information that we need. The first one is that we need to know how many isoline levels we're going to be dealing with, and we need to know what the breaks are going to be. And so let's say that you have well depths from 1 to 100 and you want 10 different breaks. So you might have 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And those are evenly spaced, but they don't necessarily have to be. And so you can either supply your own collection of doubles, which are your isoline levels, and what those breaks are, or we have a helper method, which is on the grid Isoline layer, which is static, which says get isoline levels, and you can pass in, there's a number of overloads here, you can pass in either an array of grid cells. So if you have the grid already generated, you can pass the grid in and it'll tell you, okay, we've analyzed all the grid cell values and you say that you want 20 breaks. Here's an even distribution. You can put in an array of doubles, or you can pass in a dictionary of point shape and doubles. That would be like our well values, and that's what we're passing in. And then you pass in how many isoline levels you want. So in this particular case, we're just going to that little text box on our form, where you could type in 10 or 20 or whatever it is. And so, like I said, this is going to give us something that has even breaks throughout the distribution. But you can, of course, provide your own breaks at whatever you'd like them to be. Then we're actually going to create the Isoline layer here, and we're going to pass in the grid file, the path to the grid file that we already generated up here, and we're going to pass in these isoline levels. And so that's going to allow the Isoline layer to then go ahead and generate isolines for this. But there's still a couple other things, because we want to just not have black lines, but we want to color them so you can see some differences. So the rest of this code actually just has to deal with the styling of it. And here we've done some kind of shortcuts here, and one of the methods that we have in our color system is we have the ability to get colors in a quality family. And so what that means is that you can pick a starting color, here blue, and you can pick an ending color, and you can pick how many items that you want, and you pick in what direction we go around the color wheel. And what we're going to do is we're going to create 25 different colors between blue and red clockwise on the color wheel. So this is really nice to get a set of values that are going to look pretty good, and you can pick the starting and ending point. So in this particular case, we're going to generate 25 different colors, and that's going to go into this color collection. Then we're going to set up our class breaks so that when each line goes to get rendered, it's gonna fall into one of these class breaks, and it's going to be rendered the right color. So we create a class break style. We set the first style to be the very first color in our color selection, and then we basically just loop through and assign all the styles, and we use the isoline levels, sub I, and we use the colors. We increment it by 1. And we load that class break up, and then we add that style to the Isoline layers.custom styles collection. Next thing we want to do is that we want to label these lines so you can see what these line values are. So we create a text style. The Isoline layer itself has a data value column name. And what this is that on each one of when the Isoline layer system generates the isoline, it creates a column that's associated with that line that says what the value of that line is, the numeric value. And so we can go into the Isoline layer and we can get, or we can set, the data value column name. And so we're going to grab that, we're going to use that as the basis of our text style, and then we set some different text style properties so it looks really nice when it gets done. So that's basically all there is to generating the grid Isoline layer. Of course, these class breaks, if you were to supply your own ISO levels, you can also supply your own colors as well. So this just happens to be kind of a shortcut where we can generate a whole bunch of colors and know they're going to look pretty good. So here we have the grid feature layer. This just generates the grid, and so there's another type of layer called a grid. There's another type of layer called a grid feature layer, and this is actually very useful in its own right, because before we had support for the Isoline, we had support for grid and interpolation. So if you didn't really care about isolines, you might just care about grids. You can actually create the grid using this grid feature layer. You can display it, you can do analysis on it, you could take a polygon, and since it's a feature layer, you could say give me all the cells that overlap this polygon. You can look at what the cell values are, etc. And so we use that. This is pretty much the same code that you saw just above a little bit. It's where we're going and we're getting those 25 colors again between blue and red, and we're creating a class break and assigning all that stuff in. This is so the grid actually gets colored correctly. So it's important that if you do show the grid that you synchronize the colors up so that they're going to match. The next method is to get the well depth point layer. So this is really simple. It takes those points that we loaded from that comma delimited text file, and it puts them into an in-memory layer and applies some styling to them. So it loads it up here in the in-memory layer, and then we create a point style, that shows the circle with the white interior fill, and then we have a text style, and we put a little halo around it so those are really visible, and we add that to the system, we add that to the overlay. Then here, this is and actually the control event. So in this one, whenever we hit the button to generate a new grid, what we're going to do is this kind of looks a little convoluted, but we're going to go into the map. We're going to go into the Isoline overlay. We're going to find the Isoline layer, and we're going to close it to make sure all of its memory and things are released. And then we're basically going to get a new grid Isoline layer, and we're going to call that method to generate a new one because it's going to have a new extent and etc. etc. And then we're going to set it back to that Isoline layer that was already in the system, and call the map refresh. So now if they click the generate with fixed break, so this is the one where it's actually dynamic, and as you pan it'll just keep generating. This one uses a slightly different class. It uses a dynamic Isoline layer class, but it's very similar to how the grid Isoline layer worked. And so in this particular case, we get the Isoline levels just like what we did before. When we create the dynamic Isoline layer, we include well depth data points and the Isoline levels. Here we calculate what those cell heights and widths are, and then we basically do the same thing we did in the other method. We create our colors in the quality family. We create our class break. We set up our text style. We add it to the map, and we're pretty much done there. And the last one is just whether or not to turn off the grid layer when you click the checkbox. So I think that the only other thing we kind of didn't cover on this is that when you're creating a grid, let's see, not a grid feature layer, but when you're creating a Isoline layer, remember how we said that when you create the grid, you can either create a grid file or you can create something in memory. Well, you can also come into here and use actually pass in the grid cell array, so you can keep all of it in memory if you wanted to. So that's it for the presentation, and if you have any questions, feel free to go out on the ThinkGeo forums and let us know what you think, and we'd be happy to help you. Thanks a lot. Have a great day.